Alrighty, so today I'll be showing off a simple approximation of surface tension using the weighted drop method. For this experiment, we'll need a scale, a pipette, a dish, and some different dyed test liquids to work with. So for this experiment, I used water and acetone. The water was dyed green, and the acetone was dyed blue. So the theory behind this experiment in why it works is we're able to use Tate's law, which has the surface tension force balanced with the gravitational force. Looking at that, we're able to actually rearrange the equation so that we could solve for surface tension. There is a few corrections that need to be made, and that's taken care of by the correction factor. This is due to some of the liquid being left on the pipette tip when the droplet is actually decreased. And I can show off some of that later. So for the procedure for this experiment, you go and you place a dish onto this, turn on the scale and place a dish onto the scale, and that'll show an initial reading. Then you begin adding droplets of liquid, counting the number of drops that are required to get the scale to register a new value. For the first increase, we'll throw away that value because that could be it tended to be a little bit lower than all the other values, since the scale couldn't measure quite precisely down to the part of a gram that could have possibly on whatever container that we were using. And then we'll continue this process a few times and get an average of the number of required drops to show change on the scale. So here are the results from the experiment. So this was done with both water and acetone. From the experiment, it took 50 drops of water to be able to show a visible change, and it took about 148 to 150 drops of acetone to register a 1 gram change on the scale. So from this, we were able to approximate the surface tension using the method stated before to be 85 millinewtons per meter for water and 20 millinewtons per meter for acetone. Now, since the textbook values are available for these, we're able to see roughly a overall 15% error in the recorded values and the textbook values. So here we have some of the videos recorded of the droplets getting created out of the end of the pipette. So on the left over here we have the water sample, a slight green tinge to it, and then on the right we have the acetone sample, which is the blue tinge. It can be seen between these two videos that because the surface tension is greater in the water, it's able to form a more spherical drop, whereas in the case of the acetone, because it has a factor of 3 lower surface tension, it forms more of a teardrop shape. So carrying on with the discussion, there are many different potential sources of error that were introduced at different levels of this experiment, given that this is just a sort of demonstration concept. So one of them is that there is variation in the volume within each drop, sort of caused by two different factors. One that would cause the droplets to be smaller than other droplets is that sometimes there's a part of the drop left as residual on the tip of the pipette when the drop is released, causing the drop to be smaller. And then what would cause the drop to be larger would not necessarily the drop itself, but when a droplet is grown on the tip of the pipette and then released, sometimes there's a tendency for some extra liquid to come out as the droplet is falling, sort of creating a secondary, smaller drop that would fall with the initial droplet, and that also led to some inconsistencies. Then another thing that was noticed just in the case of the acetone was that since it has a tendency to evaporate, drops that didn't land in sort of the center section where I was pulling all the drops together would evaporate and cause changes in the actual mass on the surface. So because of this, I tried to control it by sort of dropping the droplets in a consistent spot on the surface, and this seemed to help. However, it did seem to take more drops than expected to register a change on the scale. And this is definitely because we were using a kitchen scale to do these measurements with only a 1 gram resolution. And the number of drops in this experiment directly correlates to the size of your surface tension. So the more drops that are required to register a change on the scale will shrink the value of the surface tension. So overall, this method does prove to be a usable method to sort of estimate the value of surface tension, but it is not a good way to perform precise measurements of surface tension. Though it does seem, at least with these two tested liquids, that the error between them within my specific experiment was relatively consistent, being about 15%. All right, well, that is my experiment measuring surface tension using the weighted drop method. Thank you.